Hi friends, welcome to my channel. My name still remains Oluwatoyin. Today we are going to talk about the chemical properties of alkanoic acid. Chemical properties of alkanoic acid, which is also known as carboxylic acid. In today's topic, I'm going to show you logic for different chemical reaction and formation of products. So in today's topic, I will discuss about acidic properties of alkanoic acid. Under these acidic properties of alkanoic acid, we have ionization of alkanoic acid in water. Then we have reaction between alkanoic acid and highly electropositive metals. Then number three, we have neutralization reaction. Then we have reaction between alkanoic acid and triazocarbonate 4 compounds. And lastly, we talk about esterification reaction. So let's begin with acidic properties of alkanoic acid. Alkanoic acid are weak acids, so they slightly ionize in aqueous solution to release hydrogen ion. Then the hydrogen ion will be released from the carboxylic group, which is known as the functional group. The hydrogen ion will be released from the functional group. Then the general formula for alkanoic is COOH. So it shows that it's the only hydrogen ion that will be released is this hydrogen ion from the what? From the carboxylic group, not hydrogen ion from the alkyl group. So the hydrogen ion from the carboxylic group will dissociate or ionize to form RCOO minus. That is when you remove this hydrogen ion. So RCOR and RCOO plus what? Plus the hydrogen ion displace or dissociate. So which means that the product form is called what? An alkanoate ion. The product form is alkanoate ion, or you call it what? The carboxylate ion. Alkanoate ion. Alkanoate ion. Or you call it what? Carboxylate ion. Carboxylate ion. Carboxylate ion. So let's talk about the first chemical reaction under these acidic properties, which is known as what? Ionization in water. That is ionization of what? Of alkanoic acid in water. Okay? Is ionization of alkanoic acid in water. So I will explain with our general formula, which is RCOOH. Then this is ionization of alkanoic acid in water. That will be reaction between alkanoic acid and what? And water molecule. Reaction between alkanoic acid and water molecule. So the hydrogen ion will be released. The hydrogen ion will be released and react with what? With water molecule to give us what? Hydrozonium ion, which is H3O. That is, when this hydrogen ion combine with H2O, it will give us H3O, which is an ion. That is hydrozonium ion. And what? An RCOO minus. So our product form is RCOO minus and RCOO minus and what? And hydrozonium ion. So this product is an alkanoate ion. So let's use a named alkanoic acid. Let's use a named alkanoic acid. So let's use metanoic, the ethanoic acid. That is the second member of alkanoic. Let's use ethanoic acid, which is CH3 COOH plus one molecule of water. It will give us what? You displace what? Or you dissociate hydrogen ion. You dissociate hydrogen ion from the carboxylic group. So the hydrogen ion will then react with water molecule to give us what? Hydrozonium ion, which is what? H3O plus. So our product remains there will now be what? CH3COO minus. So our product will be what? An ethanoate ion. Ethanoate ion and what? And hydrozonium ion. That is the product form. ethanoate ion and hydrozonium ion. So that's all about ionization of what? Of alkanoic acid. Then number two is reaction between alkanoic acid and highly electropositive metals. B. So two or B is the reaction between alkanoic acid reaction with what? Reaction with highly electropositive metals. Highly electropositive metals. So what are those highly electropositive metals? They are sodium, potassium, magnesium, calcium, zinc, then iron. So all these can react with what? With alkanoic acid. With alkanoic acid. This chemical reaction is similar to reaction between mineral acid and what? And metal. Don't forget that when a mineral acid reacts with any metal, the metal will displace hydrogen from the acid and occupy the position of the hydrogen. When a mineral acid reacts with any metal, the metal will displace hydrogen from an acid and occupy the position that of that hydrogen. So the same what? The same thing applicable to what? To this chemical reaction, because alkanoic acid is an organic acid. So likewise, metals will displace hydrogen from the carboxyl group and occupy the position of that hydrogen. So let's take the general formula of alkanoic, which is RCOOH. RCOOH plus a metal. Let's take a metal for example, that's sodium Na. So what this metal will do is that it will displace hydrogen, that is, it will remove hydrogen from the carboxylic group. That is, your carboxylic group is what? Is COOH. It will displace this hydrogen and occupy the position of the hydrogen. So therefore, our product will now be RCOO. That is, sodium will come in Na. Then hydrogen will now be what? It will be liberated in form of gas H2. So it shows that when an acid reacts with any metal, there will be what? Liberation of what? Of hydrogen gas. A colorless and odorless gas, which gives what? A pop sand with lightest plane will be what? Will be evolved. So that gas is what? Is hydrogen gas. So let's use a name alkanoic. Let's use a named alkanoic. Let's use the ethanoic acid, which is CH3COOH plus a metal. Let's use calcium this time around, Ca. What will be our products? So this metal will displace hydrogen from the carboxylic group of an alkanoic acid. So this hydrogen will be displaced and the metal will occupy the position of the hydrogen. So the hydrogen will be liberated in form of gas, so H2. So then this metal will come here. Then let's look at this. The CH3 COO minus. Then calcium that want to come in is what? Is 2 plus. Calcium is 2 plus. So it means that we need two of these to combine with calcium to give us a compound. So minus 1 will not cancel plus 2. So we have to multiply this one by what? By 2. So minus 1 times 2 will give us minus 2. So therefore our product will now be CH3 COO into bracket 2 Ca, then plus what? Plus hydrogen gas. Hydrogen gas. So that is the product form. So our product form is called what? Calcium ethanoate. Calcium ethanoate. Because the product from anion form is called what? Is an alkanoate. Anion form is an alkanoate. And this is the second member of what? Of alkanoate, because we have two carbon atom from this molecular formula. So therefore, it is the second member of alkanoate. So we just call it what? Calcium ethanoate. Calcium ethanoate. Calcium ethanoate. Calcium ethanoate. So let's take another example. Let's take another example. I'm going to use another metal and another what? Another alkanoic acid, another member of alkanoic acid. Let me use CH3. Let's use C2H5 COOH, which will be the third member of what? Of alkanoic, because we have two carbon atoms here plus one here. That is three carbon atoms. So an alkanoic with three carbon atoms is called what? It's called propanoate. So this is propanoate. Reaction between propanoate and potassium K. So the potassium will what? Will displace hydrogen and will occupy the position of hydrogen. So the metal will come here and hydrogen will be displaced. So therefore, don't forget that C2H5 COOH is C2H5 now. C2H5 COO minus, because an electropositive what? An electropositive atom is being displaced. So we have electronegative now, one electronegative. So potassium is what? Is plus. So plus we cancel minus. So they will come together to give us what? C2H5 COOK. Then plus the hydrogen will be what? Will be liberated in form of gas. So plus H2. So H2 will be evolved in form of gas. So that is the product form. So what will be our product? Let's name the product. Let's name our product. K is potassium, and we have three carbon atoms. This is the member of alkanoate. So three carbon atom, that will be propanoate. So we call it potassium propanoate. Potassium propanoate. So our product form is potassium propanoate and hydrogen gas. So let's move to the third chemical reaction, which is known as what? Neutralization reaction. Under inorganic chemistry, what is neutralization reaction? Neutralization reaction is a chemical reaction between acid and base. Reaction between acid and base to form what? Salt and water only. So alkanoic acid is an organic acid. So when an organic acid reacts with a base, your product form will be an organic salt. It will give you an organic salt. So let's look at chemical reaction between alkanoic acid and base. So C is neutralization reaction. Neutralization reaction. That is reaction between acid. So what are we talking about here now? Organic acid, which is an alkanoic acid, RCOOH. Reaction between organic acid and what? And base. And base. So let's use sodium oxide. Sodium oxide is what? Is an oxide of metal. Is an oxide of metal. Then it is a base. So reaction between sodium oxide and alkanoic acid, which is alkanoic acid is an organic acid. So our product form must be and what? Must be an organic base, an organic salt. Your product form must be an organic salt and what? And water. Then the hydrogen atom will dissociate. So this compound will be broken down into RCOO minus and what? And H plus. That is the hydrogen atom displaced. Then at this side, we have sodium, Na. Then the charge on sodium is plus. Then oxygen is what? Is 2 minus. oxygen is 2 minus. Then our method of formation of product, positive and what? And negative will combine together. Negative we combine with what? With positive. So this negative we cancel positive to give us RCOONA. RCOONA. Then hydrogen we combine with oxygen to give us water molecule. So the charge on this one is +1. We have to multiply this one by 2. So +2 now we cancel -2 to give us what? H2O. H2O. So our product form is now what? Sodium what? Sodium alkanoate. Sodium alkanoate, which is an organic salt and what? And water. Sodium alkanoate and water. So let's take a named alkanoic acid. Let's use ethanoic acid, which is CH3 COOH plus, I'm going to use another base this time around. Let's use calcium oxide as a base. Calcium oxide is what? Is a base. So reaction between calcium oxide and an organic acid, which is ethanoic acid, will give us what? The compound will what? The hydrogen ion will be released. So therefore, these products will be splitted into CH3 COO minus and what? And H plus. Then your calcium oxide will be splitted into Ca. The charge on calcium is 2 plus. Then oxygen, which is what? Which is 2 minus. Then our method of balancing or chemical equation and formation of products. To form our product, the positive we combine with what? With negative. Positive we combine with negative. Then on this negative we have -1, which is the same thing as minus. So minus will not cancel +2. So we have to multiply this side by 2. So you multiply this one by 2. So when you multiply this one by 2, that will be -2. We cancel +2. So the -2 will be able to cancel +2. The 2 will come together to give us CH3 COO. Since they are together, you have to put in bracket 2. Then you combine with what? With Ca plus. Then hydrogen and what? And oxygen. Hydrogen is +1, oxygen is -2. You multiply this one by 2 to give us +2. So +2 we cancel -2 to give us what? H2O. H2O. So that is the product form. So our product form is now what? Calcium ethanoate. Calcium ethanoate and water molecule. Calcium ethanoate and water molecule, which obeys what? This neutralization reaction. Because neutralization reaction is a chemical reaction between acid and base to form what? Salt and water. And this is an organic salt and what? And water. So the next one is reaction with triazocarbonate 4 compounds. Reaction with compounds of triazocarbonate 4. Then reaction with triazocarbonate 4 compounds. So what are the compounds of triazocarbonate 4? E.g. sodium triazocarbonate 4, that is NaCO3, Na2CO3. We have calcium triazocarbonate 4, which is CaCO3. We have sodium hydrogen triazocarbonate 4. Sodium hydrogen triazocarbonate 4, which is NaHCO3. So when any acid, under mineral acid, when an acid reacts with triazocarbonate 4, there will be effervescence of colorless and odorless gas. Then the gas turns lime water milky and blue litmus paper to red. So therefore the gas is what? Is carbon 4 oxide. So it shows that when an acid When an acid reacts with any triazocarbonate 4 compound, there will be evolution of what? CO2 gas. There will be evolution of CO2 gas. So the same thing applicable to chemical reaction between alkanoic acid, because alkanoic acid is an organic acid. So when alkanoic acid reacts with any triazocarbonate 4 compound, there will be effervescence of what? Of CO2 gas, which is carbon 4 oxide gas. So let's see the chemical reaction for that. Reaction between alkanoic acid, which is RCOOH, plus a triazocarbonate 4 compounds. These are triazocarbonate 4 compounds. You can use any of the compound. Let's use Na2CO3. So what will happen once this triazocarbonate 4 compound come in contact with an acid? There will be evolution of carbon 2 oxide. So the CO2 will be released from the triazocarbonate 4 compound. So when you remove CO2 from this CO3, you will be left with Na2, then one oxygen. Remove CO2 from CO2, it will give you Na2O. So which means that our product we first release what? CO2 gas. CO2 gas will be what? We evolve. CO2 gas will evolve. Now, what will be the next product? What will be the remaining product now? The hydrogen ion will be displaced. So we are going to have RCOO minus and H plus. Then this one will now decompose to Na and oxygen. So Na is plus, oxygen is what? Is 2 minus. So positive we combine with what? With negative. Positive and negative we combine together. So minus 1 we cancel plus 1 to give you RCOO Na. Then plus, then we have hydrogen and oxygen. So hydrogen will combine with oxygen to give you what? H2O. Then plus what? B plus the CO2 gas that's evolved from triazocarbonate 4 compound. So our product form is now what? Sodium alkanoate, water, and what? Carbon 4 oxide. Carbon 4 oxide. So let's use a named alkanoic acid. Let's use a named alkanoic acid. Let's use ethanoic acid, CH3COOH, plus another what? Let's use another triazocarbonate 4 compound. That's NaHCO3. NaHCO3. So once this sodium hydrogen triazocarbonate 4 reacts with an acid, that's ethanoic acid, CO2 will be evolved. So you remove CO2. CO2 will go out. So you will be left with what? NaH and one oxygen. NaH, then OH. So this one will now decompose to CH3, COO minus. So the hydrogen what? The hydrogen ion will be released. So sodium is positive. Then why hydroxy ion? So this is OH now. Why hydroxy ion is what? Is negative. So the oxygen and hydrogen will give us hydroxy ion. So we take positive and negative. So positive we combine with negatives to give us CH3 COO, that is CH3CO, we combine with sodium Na plus, then the hydrogen ion will combine with hydroxy ion to give you what? H2O. H2O. So our product form is now what? Sodium ethanoate, because this is the second member of alkanoate. Sodium ethanoate and what? And water. Sodium ethanoate and water. Then plus CO2 gas, because CO2 gas will what? Will be evolved. So plus what? Plus CO2. Plus CO2 gas. So that is the product form. So Just have it in mind that when there is what chemical reaction between an acid and triazocarbonate 4 compound, so CO2 gas will be what will be evolved. So the last chemical reaction here for today is esterification reaction. Esterification reaction. Then the word esterification means formation of ester. Formation of ester. Then ester is also known as alkanoate. Ester is also known as alkanoate. Then how can we form ester? So esterification reaction is a chemical reaction between alkanoic and alkanol in the presence of concentrated H2SO4 as a catalyst. In the presence of concentrated H2SO4 as a catalyst to form alkanoate, and water. So with this chemical equation you can define esterification reaction. Esterification reaction is a chemical reaction between alkanoic. This is the general formula for alkanoic. It's a chemical reaction between alkanoic and alkanol in the presence of concentrated H2SO4 to form alkanoate and what? And water. So this is the general formula for alkanoic. This is alkanol. This is alkanoate. So to give us water. So it shows that when alkanoic acid reacts with an alkanol, your product form will be alkanoate, which is also known as ester. Or ester. So to form ester and what? And water. So let's take a named alkanoic and alkanol. I'm going to use ethanoic acid. That's CH3COOH. So this is an alkanoic. Then plus alkanol. Let's use ethanol. That's C2H5OH. So this is alkanol and alkanol. Then to give us what will be our product form? So hydrogen will be displaced. So this compound will be splitted into CH3COO minus. Then hydrogen will be released, hydrogen ion. Then this one will be composed to C2H5. This is plus. Then plus what? OH minus. So our method of formation of product, positive we combine with what? With negative. Positive we combine with negative to give us CH3, COO, C2H5. Then hydrogen ion we combine with hydroxy ion to give us what? To give us H2O. So that is our product form. So can we name the product form now? This is ethanoic acid. This is ethanol. Then this is an alkanoate now. Then don't forget that alkanoate member we always name from the back to the front. So we first name the what? The R and alkyl group at the back before we name the root hydrocarbon. Now C2H5 is the second member of what? Of alkyl, which is called ethyl. Ethyl. So we call it ethyl. Then this is the root hydrocarbon, which is an alkanoate. So an alkanoate with two carbon atoms is called what? Ethanoate. So our product is ethyl what? Ethanoate. Ethyl ethanoate. Ethyl ethanoate. So reaction between an alkanoic and alkanol will give you an alkanoate and what? And water. We give you an alkanoate and water. So they can give you any members of alkanoic. They can give you any members of what? Of alkanol. Alkanol. So just know that the alkanoic acid will release hydrogen ion. Then the hydroxy group will be released from the alkanol and combine with hydrogen ion to give you what? Water molecule. Then the positive part of the hydroxy ion will react with the negative part, that is the alkanoate ion, to give you what? An compound of what? Of alkanoate. To give you compound of alkanoate. So we have come to the end of today's class. In my next video, I'm going to explain combustion of alkanoic acid. I will explain reduction of alkanoic acid. Then I will explain substitution of alkanoic acid with halogens. Then I will explain reaction between alkanoic acid and phosphorus 5 chloride and the thionyl chloride. The thionyl chloride. Remember to subscribe to Royal Learning Channel. Share this video with your friends, with your family members, and don't forget to comment. Don't forget to comment. See you in my next video. Bye.